change gears a little bit to get to more abstract patterns. I know probably nobody on the line here creates these colanders, but this is really to show you a varying type of a pattern that we've created based on tables. So we've got a hole pattern out here. That's a pretty simple one, but we've also got a slot. Now this slot is then the seed feature for the pattern that you see here. And I want to show you how this pattern actually gets generated. So let's take a closer look. I'm going to grab the slot, and under our pattern tools we now have a new pattern feature called the variable pattern. By selecting this, it's going to walk us through the features that we want to pattern, and then maybe some reference geometry also used to drive this feature. We can insert those either pre-selecting like I've done here or after the fact right now. But essentially this pattern is generated by using a table. Now the tables can be pretty simple, they can be pretty elaborate. The table that I'm going to use here is going to drive 3 dimensions, and we're going to do that by selecting those values now. What I want to do is I want to drive this angle, this offset distance of where the slot is from the center point of our colander, and then the length of the slot itself. And all those are gray because they're based on the feature itself. We're going to add 1 row to this table and see how things look. Now I want to change the angle first of all. I'm going to change it by not really thinking too much and simply typing in 360 divided by 20. Hit enter, and just like Excel, you're going to get the actual math value of that. These other 2 dimensions, not quite as sophisticated. I'm just going to click and change each of those. Once I do that, if we simply update the preview, what you'll see here is the additional instance right up here to the top. Now if that looks good for you, what we can do is then go ahead and really populate this thing in a very big way. To do that, I'm going to add 18 additional rows. Now these rows are all filled out based on the initial instance value, but using Excel-like functionality, I can populate these pretty quickly. So down here I can grab the 0 and the 18, and just like Excel, if you grab the corner of the cell and drag it down, it will increment them up based on the transform between the 2 cells that are selected. So very quickly I can add in 18-degree increments for each instance. This part over here is not quite as sophisticated. I'm just going to right-click and copy those, and then paste, paste, paste. This will be fairly repetitive. You only have to paste so far. In this case I'm going to take it only down to the 8th row and simply copy and paste the additionals of those. That said, when we update the preview, now the entire chart takes effect, and this is what we see on our part. So each individual instance being driven by an individual row within this table. So once we say OK to this, we get a very elaborate pattern, but based on a pretty simple input. Now this thing really is quite nice when it comes to the feature result itself. What you'll notice here is that it's not just a feature, but it's actually got several instances within that feature. So if I wanted to click on any individual instance, I can actually action on those individually. I'll change the length of one instance versus the other. It's as if I changed the length of that feature on the table. If I want to go ahead and take any feature instance and suppress it, it's going to suppress just that instance, but not the variable pattern feature. Or, likewise, if I take a feature and simply hit delete, it's as if I went ahead and deleted row 3 or instance 3 from the table, but does not delete the entire pattern feature. So that one's quite sophisticated. The hole pattern that we have there is actually just a basic hole. We have a circular pattern of 36 instances, and with each individual setting for this, we've simply changed the diameter of the hole pattern and the number of instances of those holes. A few more that are really elaborate here. We're just going to go to our football spikes in this case. We have a variable surface. This is a boundary surface, but it could be imported geometry. And we've taken these spikes and we've created a variable pattern off of this initial seed feature. Now the seed feature was made in a very smart way, a smart way that's going to be effective with this complex face. It was built by putting a 3D point coincident to that face. Now what that means is as this feature gets patterned, that 3D point has to stay coincident to that face. On top of that, there's a plane tangent to this face through that point. So by patterning both of these, we'll start to get that these spikes are going to change to stay normal to the face as they get patterned. So in fact, the pattern itself has nothing to do with the orientation of these. It's all the smartness of the way the plane in the initial instance was created. From there, it's just an extrude, a cut, and a fillet. So with each of these instances, and I'm going to show you the actual table for this, all we're really doing on this is simply changing the XY position, the angle of attack, and then the length of each of those spikes, because you see the ones in the back are 24 and the ones in the front are 18 millimeters. So what that'll do is give you a very effective pattern, quite complex, but all built off of one single seed input. Gives us also the ability to individually grab a dimension for one of those instances and simply change its position independent of all the rest. As it moves to the left, it'll actually tilt back slightly. Kind of hard to see during the rebuild, but because those planes and points have to stay normal and tangent, those are going to all change the orientation and shift the position of those spikes. Last one I'm just going to pull up just to show you what the feature looks like is another shoe, but this one's a bit more complex when it comes to the cutouts that we've got here. This is a spline and a sweep cut, and all we're doing is actually changing the spline shape as we're moving it along. So you see that the spline goes from more of a mountain type of a shape to more of an arc shape as it transitions from one end to another. And then we're taking the depth of that cut and modifying that. Some it goes part way, looks like this, and some it goes twice as deep. So very cool. Really the applications for this are open-ended, nearly endless, but very nice functionality added to our pattern tools.